We have looked at structure, preparation, properties and reactions of phenol. The hydroxyl group in phenol aliphatic carbon attach பண்ணாம aromatic carbon attach ஆயிருக்கு. இதனால though the compound has the same functional group, அதனுடைய reaction properties எல்லாம் different இருக்கு. இது வந்து various phenolic groups outline. We have seen this: phenol, metacresol, paracresol, catechol, resorcinol, hydroxyquinol, 2,4-dinitrophenol, naphthalene ring இருந்தாக்க 1-naphthol, 2-naphthol, 4-amino naphthalene sulfonic acid. We looked at the manufacturing process, the Dove process involving chlorobenzene and sodium hydroxide at high temperature and pressure, cumene hydroperoxide method, where this is the isopropyl benzene, which is called cumene, is oxidized to cumene hydroperoxide, reacted with H3O plus, gives phenol and acetone, important side product. This reaction takes place at low temperature, therefore it is environmentally friendly, so you can use less energy. Then another process is fusion of sodium salt of aromatic sulfonic acid with sodium hydroxide gives phenol. In the laboratory, the fusion method is still used, but the most commonly used method is diacetyze amines and then warm them to 15 to 30 degrees. The diazonium salt is hydrolyzed and forms phenol. Then its physical properties: phenol is higher boiling point compared to molecules of similar molecular weights because of hydrogen bonding, intermolecular hydrogen bonding, and the same is true of solubility due to intermolecular hydrogen bonding. Phenol is very acidic because the anion is very stable by resonance of the O minus into the ring, both the two ortho position and the para position. This is how it's shown here, and the acidity range is paranitrophenol is stronger than phenol, which is stronger than paracresol. இது எதனாலனா paranitro group withdraws the electron, makes the hydrogen ionize easily. இதில் வந்து இந்த withdrawal கிடையாது, இதில் வந்து electron donation, methyl group donates electron, the OH group is stronger, அதனால அது ionization is difficult. This is the phenol and this is the phenoxide ion. It shows the resonance of the phenol and the phenoxide ion. The resonance structure is here. இதில் separation of charges இல்லை, இதில் separation of charges இருக்கு. இது unstable, இது more stable. That is why phenol is a very strong acid compared to alcohols. Phenols form esters like with the propyl C2H5COCl and C3H5SO2Cl and C6H5COCl. These are all acid chloride prepared from the corresponding acids. It reacts with the phenol hydroxyl group, forms the propoxy, the C2H5COO, C6H5SO2O, C6H5COO, ester forms. The electrophilic aromatic substitution, we looked at groups which form positively charged intermediates like nitric acid with sulfuric acid forms NO2 plus, it attacks ortho or para position of benzene ring. They give orthonitrophenol and paranitrophenol. Two molecules of sulfuric acid reacts by protonation to form SO3H plus. This is the electrophile. This attacks phenol, orthohydroxybenzene sulfonic acid and parahydroxybenzene sulfonic acid. Usually this is produced at lower temperature, this is produced at higher temperature. Similarly, bromination, bromine reacts with water and acid to form the bromonium ion, Br plus, chlorine similarly, and this will react with in water bromine gives tribromophenol, in carbon disulfide it gives parabromophenol. Likewise, nitrous acid, which is obtained from sodium nitrite and HCl, this gets protonated to form NO plus, which attacks the benzene ring to form orthonitrophenol, mostly para-nitrosophenols. Now we started out today this with Friedel-Crafts alkylation. If you take tertiary butyl chloride treated with HF, it forms tertiary butyl cation. Because of its bulk, it attacks the para position to form para-tertiary butyl phenol. Then Friedel-Crafts acylation, we looked at the reaction of CH3COCl with benzene with phenol in the presence of aluminum chloride. Aluminum chloride abstracts the chlorine of the acyl chloride as Cl minus and forms CH3CO plus. This is electrophile. The CH3CO plus ortho or para position attack ஆகுது. If you have phenol treated with acetic anhydride, இது ஒரு ester form ஆகுது, acetate. அது acetate aluminum chloride ஓட ஹீட் பண்ணாக்க you get either para acetate group, para acyl group or ortho acyl group. So this is more stable, this is less stable. That coal-based synthesis and Reimer-Tiemann reaction, phenol plus CO2 forms orthohydroxy benzoic acid, sodium salt. Acidification gives orthohydroxy benzoic acid, which is salicylic acid. Reimer-Tiemann reaction, you take phenol, chloroform and base. This forms carbene. Carbene reacts with the ortho position of the phenol ring and then it forms CHCl2, hydrolyzes, forms the aldehyde, orthohydroxy benzaldehyde. Diazotization we have seen earlier. Coupling, this diazonium salt couples with phenol at the para position with the naphthol at the 4 position with 1 naphthol, 2 naphthol at the 2 position. This naphthalene sulfonic acid, it will remove the sulfonic acid group, form a diazo group there. Here you can control the pH and get diazo group here and also diazo group here. Claisen rearrangement, this we just see the 3,3 sigmatropic rearrangement and formation of ether. It can form from aromatic O minus with alkyl halide, provided the halide is primary. Secondary and tertiary will give accompanying elimination, the alkene form ஆகும். அதனால primary and secondary, primary only the ether will be formed, no alkene. So it's better to use the primary bromide to form ether. And you can have ethyl bromide, propyl bromide. When you get ethylene oxide, it reacts to form the extension of the ether group by 2 carbon atoms. The cleavage of alkyl aryl ethers, if you treat it with HI, it forms phenol and ethyl iodide. Aromatic ethers can undergo electrophilic substitution more readily without much problem with the hydroxy group if phenol is reacted. And when you have this ethoxy group, you can easily oxidize the ether with permanganate and hydroxide to form the carboxylic acid. The same reaction cannot be done with phenol because it will get oxidized in the ring.